So far, folks, we have said you can solve a system, and somebody remind me what a system is. Two or more equations. In fact, we're using two of them, right? We have two ways to solve them so far. What was the first way that we solved these things? Graphing. And the answer was where they crossed. What was the second way that we solved these things? Substitution, and you had to get one of the variables alone, correct? And then plug it in. Today, we're going to talk about the third way, and you can see up here that's called elimination. Fair enough? Okay, in order to do elimination, you need to remember what additive inverses are. What does it mean to be additive inverses? Yes? Yeah, basically they're opposites, and so when you add them, you get 0. So what is the additive inverse of 1? What is the additive inverse of 5? Excuse me, of negative 5. It is positive 5. What's the additive inverse of 7? Of a half? Of negative 6? Of 8x? And of negative 2y. So how we doing, folks? Do you understand what an additive inverse is? Okay. Now, we've named these ways appropriately. If I tell you to solve by graphing, you graph, right? If I tell you to solve by substitution, you substitute, right? So if I tell you we're going to solve by elimination, what do you think we're going to be doing? Eliminating. Okay, what does it mean to eliminate? Take away, get rid of. Okay, so, everybody okay with this slide? Can I move on? Yeah? So if I ask you to eliminate, you are going to try to get rid of a variable by creating additive inverses. And folks, remember, additive inverses is just a fancy way of saying opposites. If you don't have additive inverses, you have to make them, and I'm going to show you how to do that. Please be sure both equations are in standard form. Now, if you remember, standard form is not something that we have used very often. We kind of briefly touched on it, and then we moved on to slope-intercept form, didn't we? Okay, so what is standard form? Standard form looks like that. Basically, it needs to be in the right order, is what standard form means. X's, then Y's, then your equal sign, then your constants. But folks, how many equations are you going to have if it's a system? 2. So this would be what your first one would look like. But then I'm going to have another one that also has to be in standard form. Okay, so both of them have to be in the correct order. And I want you to notice that I stacked them on top of each other, didn't I? Do you see how the x's line up, the y's line up, the equal signs lined up, and the constants are lined up, yes? That is going to be key. All right, so I'm going to try and get this couple examples in before you guys leave so you can see what we're doing, okay? So take a look at number 1. And again, let's just do one, write it down, and then we'll move on to the next one. First question I have for you. Are they both in standard form? They are. Do either of those variables look like additive inverses? Do you all see how one of them is a positive 1y and the other is a negative 1y? Great. That means I'm going to be able to eliminate the y's. In order to do that, we are going to be adding these equations. You guys remember when you first learned how to add and they had you stack them up and line them up? That's what we're doing here. Okay, if I add my x's, how many x's do I get? If I add my y's, how many y's do I get? Because they are now eliminated. Do you all see why we call it that method, right? So these have been eliminated. Equals 30. Now, is this something that you know how to solve? Absolutely. How would you solve that? So x is, but how much of your answer is this? That's half of your answer. You have to take this 5 and use it to find the y, which means you're going to have to plug it back in. But folks, it does not matter what equation you plug that into. Because don't they, when they cross, both lines have to have this point on it, doesn't it? So it doesn't matter which one you plug it into. I like to use the ones with the positives or the better numbers. So in this case, I would probably put this in right here. So that will be 2 times 5 plus y is equal to 18. Does everybody see where that came from? Yeah? So what is 2 times 5? So this is now 10 plus y is equal to 18. And then what is y? 8. So if you were to graph these things, where would they cross? And that's elimination. Questions for me? No? We sure? All right, let's try number 2. You guys can go ahead. Take a look at number 2. Are they in standard form? They are. Are either of them additive inverses? Which ones? The t's are additive inverses. So I am going to add them. Okay. If I add them, how many s's do I get? How many t's do I get? None. They have been eliminated. How about your constants after the equal sign? Solve for s. S is 3. Now we need to take that 3 and find the rest of our answer. So we're going to take that 3 and put it either into the top or the bottom. It really doesn't matter. I'm going to choose the top. Make sure you put it in for the right variable. You will get the wrong answer if you put it in for the wrong variable. So this will be 3 minus t is equal to 4. So what is t, folks? So these things would cross. Uh-oh, what's the order? Yeah, S then T, right? You're saying your ABCs in your head, I hope. What's up? So you can put it in either equation. What do you guys think? Yes, either equation. Yep, either equation. Pretty good, right? Okay. Take a look at the next one. He says right away it's not in standard form, is it? So I need to get it into standard form. First of all, which equation is not in standard form, the top or the bottom? The first one. How would I get it into standard form? Yeah, the first thing I got to do is move this 5y over. So now I have 3x minus 5y is equal to what? Negative 16. How's everybody doing now? And now they're stacked up nice and pretty, aren't they? Okay, look at your x's and look at your y's. Are either of them additive inverses? Which ones? The y's, which means when I add them, the y's will be eliminated. How many x's will be left? Equals, how about my constants on the end? 15. So what is x? 3. Now, here's where I need you to make sure. I would really prefer that you go back to an original equation. This guy right here is not an original equation, is it? No, I would go back to one of them that you started with. Could you still possibly get the same answer? Yes, but there's less room for error if you go back to the original. So let's take that 3, and I think I'm going to plug it. Well, it really doesn't matter. You tell me, top or bottom? Top, I heard first. We'll go there. So it goes in for x. So this will be 3 times 3 is equal to 5y minus 16. What is 3 times 3? Solve it. What is y, folks? 5. How we doing? Good. Did anybody plug it into the second equation? Did you get 5? Great. Doesn't matter, right? Okay, so what is the point, the ordered pair these things will cross? 3, 5. Of course, you could check it by plugging 3, 5 into both equations and seeing if it would work. Did I tell you guys how many examples I have for you today? No? Let's see how many I got. I've got 10. Okay. All right, take a look at number 4. What do you think? Which one's not in standard? The bottom one. You all see how that minus 18 is on the wrong side of the equal sign? How are you going to move it over? You're going to add it. So now I have 3x minus 6y is equal to a positive 18. And then I'm going to drop down that other equation. It doesn't matter which equation is on top and bottom, folks, because when you add, does it matter which number you add first or second? It does not. Oh, I guess I didn't ask. Are either of them additive inverses? The x's. Okay. So what happens when I add my x's? They are eliminated. There are 0 of them. What do you get for your y's here? And your constant? So what is y? Okay. Where would you like to put that? The first or second original equation? First. So I'm going to put it right there. Notice it's going in for y. So I have negative 3x plus 4 times negative 15 is equal to 12. What is 4 times negative 15? Solve it. What's x? You guys speak up. I got these things in my ears. Negative 24. So where do they cross? Negative 24. Negative 15. Okay, so let's talk a little bit here before we go on to our next example. Your other two methods are graphing and substitution, yes? Look at these original two problems. Would they be easy to graph? Really? To graph, I got to get the y by itself, don't I? So for both of those, you'd have to get the y by itself first, wouldn't you? And then you'd have to graph it, and it crosses here, doesn't it? That's a pretty big graph to cross at negative 24, negative 15, isn't it? Well, my other option before today was substitution, yes? Would it be easy to substitute for these things? Not really, because I don't have a 1 or a negative 1 as a coefficient, do I? You don't, so you'd have to look for something else, and you'd probably say, I'm going to solve for this x in the second one, wouldn't you? Because the 3 can divide all of those, yes? But that would still take you a decent amount of work, wouldn't it? Whereas elimination probably would be the easiest. So depending on the problem, one method might be easier than another. Fair enough? Okay, let's move on. Take a look at number 5. Are they in the correct order? They are. Do I have additive inverses? I do not. So I'm going to have to make them. Here's where I ask you, which one would be closer to being additive inverses, the m's or the n's? The m's are really close. They're just both positive 2, which means I need to make one of them a negative 2, correct? Now, I can't just go in there and say, okay, let's make this one negative. I can't just do that, yes? Changes the whole problem, doesn't it? So how do I make it negative and still, hold on a second, and still make it legal and not really change much? Correct. We're going to take, does it matter which equation I multiply by -1? It does not. We're going to take the entire equation and multiply it by -1. As long as you do it to the entire equation, everything's still legal. So when you do that, I now have -2m plus 5n is equal to 6. You must distribute that throughout the entire equation. Now, do you have additive inverses? You do. So now we're right back where we were before. We're going to add these two equations up. How many m's do you get? None. How many n's do you get? -2. And your constant? -8. How are we doing? Now, folks, I need you to stop because I know you guys are frantically answering this question. But would it have mattered if I multiplied this bottom one by -2? It wouldn't, but your numbers might be a little bit different, but you're still going to get the right answer. Okay? So what's n here? 4. Now remember, I want this to go back into an original equation. So you want to go with the top one or the bottom one? Bottom. So this is going to go right there for n. Good? 2m minus 7 times 4 is equal to -14. You go ahead and solve that. What's m, folks? Should be 7. Should be 7. So where do they cross? Correct. Alphabetical order tells me 7, 4. All right, let's try another one like that. Take a look at number 6. Are they in the correct order? They are. Do they have additive inverses? They don't. So you need to make them. Okay. We've already shown that we're going to multiply the equation by something, right? Okay. So you have to make a decision. You have to decide if you want to eliminate the x's or if you want to eliminate the y's. If you eliminate the x's, if this top one has a 4x, you're going to have to make the bottom one -4x. Agreed? If you eliminate the y's, do you see how that's -12? Yes? So I need to make this one a +12, don't I? Agreed? Could you go the other direction? Could I say, okay, this one is a +2, I need to make that one a -2? Could you multiply 12 by something to make it come down to -2? You could, but it's going to be a fraction, isn't it? Not very easy. Agreed? So I would not recommend trying to make positive a -2. I would recommend either trying to make positive a -4 or positive or -12. Does it matter which one you choose? It does not. So what do you think? You want to cancel out x's or y's? Okay, so that means I am going to have to multiply the bottom equation by what? All right, so when I do that, I get -4x minus 8y is equal to -8. Then I'm going to drop down the top equation. And now I'm going to tell you to solve it. Go for it. What are you getting for y? So then we plug it in. And what are you getting for x? So where would these two lines intersect? There we go. How we doing? Still good? Okay. Couple more. As you look at number 7, are they in the correct order? They are. As you look at number 7, do they already have additive inverses? They do not. So you're going to need to make the decision to either cancel out the x's or the y's. Now, one of them is actually easier in this problem. Should I cancel out the x's or the y's here? The y's, because all I need to do with the y's is multiply that top equation by what? By 3. So I get 15x minus 6y is equal to negative 30. And now you have additive inverses and you're able to solve. Go ahead. All right, so I hear some calculators going. Because what is x? 1 2/3. You could have that as 5/3. You could also have that as 1.6 repeating. But is it going to be very easy to type in 1.6 repeating in your calculator to find the y value? No. So please use the fraction form. I chose to put mine in the second equation. Okay, so what is 3 times 1 2/3? 5. Then we have to subtract the 5 over, and that gives me what, 55? And then we have to divide by the 6, and that gives you another fraction, doesn't it? What is it? What is the fraction answer to that? 9 1/6. So, is this a problem that you wanted to graph? No way, because there's no way you would be able to guess these decimals on a graph. And even Desmos is not going to give you the repeating decimal. It's only going to give you 3 decimal places. We still doing okay? You sure? Okay, so let's take a look at number 8. In number 8, are they both in standard form? Do either of them have additive inverses? No. In fact, neither of them are even close to having additive inverses, are they? If you look at your x's, there is no way I can multiply 2 to get to be a negative 3 unless I use a fraction, right? And there's no way I can multiply 3 to get to a negative 2 unless I use a fraction, agreed? And the same is true for the y's. So this time you're going to have to multiply both of them. Okay? What numbers do you think you would be trying to make if you wanted to eliminate the x's? Yeah, you want to make positive 6 and negative 6. What number would you try and make if you're going to eliminate the y's? 12 and negative 12. So which way are we going? Are we eliminating x's or y's? Okay, so what are you going to multiply the top equation by? Which one is it? Does it matter? Not really, does it? Do you want that one to be negative or positive? Negative. Okay, so we'll make that one negative. So then what will you multiply the bottom equation by? should be positive 2 because I already had my negative taken care of up top, didn't I? Okay, so my new equations are negative 6x minus 9y is equal to, what is that, negative 42? And then 6x minus 8y is equal to 8. And now you have additive inverses, and you're ready to go. Bless you. Go ahead and solve it. When you find the y, go ahead and find the x. Bless you. What are you getting for the y? I chose to put mine into the second equation. No, excuse me, the first equation. So then 3 times that 2 is 6. If you subtract that 6, you will get 8. If you divide by that 2, you will get 4. So your ordered pair is 4, 2. Questions for me? Big fat no? Okay. I've got 2 more. Why don't you solve these 2 equations? If you want to work with a partner, that's fine. When you get your answers, let me know. I'll come over and check them, and then we'll call it a day, okay? Yes? Okay. Go ahead. If you want to move, that's fine.